Hi everyone, today I'm just going to go through two basic examples of using Pythagoras Theorem to find out an unknown side of a right angled triangle. The first example I'm going to show you is finding an unknown hypotenuse. Now, hypotenuse is the side that's directly opposite the right angle, and that's the longest side of a right angled triangle. So when you get to the end, you can always check your answer to make sure if you're on the right track to see if it is in fact larger than the other two sides of the triangle, because the hypotenuse should always be the highest number. Now, I'm going to show you the process for Pythagoras. I think it's quite easy because it's more just about following the steps. My first step for solving these questions is to actually draw the triangle, put in the information you've got, including the x or the pronumeral for the unknown side, and then what I'm going to do is start by writing Pythagoras' theorem, which is a squared plus b squared equals c squared, or the sum of the two shorter sides squared is equal to the hypotenuse squared. Now, step one, you've drawn a triangle. Step two, you've got Pythagoras' theorem. Now let's go and actually label this triangle with those values a, b, and c. We know c is the hypotenuse, so a hypotenuse we can label with a c, and the other two sides we can label a and b. It doesn't really matter in this case which one's A and which one's B. Once I've done that, I'm going to actually then use those values and basically substitute them into the equation I've got here, Pythagoras' theorem. So instead of the value A, I'm going to use the number 5. Instead of the value B, I'm going to use the number 9. And instead of C, I'm going to use, in this case, the pronumeral X. Okay, now it's just about, solving this equation, and we do that first by squaring 5, so 5 squared, remember it's 5 times 5, which is 25, 9 squared, 9 times 9, 81, and that's equal to x squared. Then we can simply add these two numbers together, 25 plus 81, 106. So we're at this point where 106 is equal to x squared, or a number times by itself is equal to 106. Now that's not a whole number. If you know square numbers, 106 isn't a square number, but we can use a calculator to work that out. So the correct working out to show would be x is equal to the square root of 106. Okay, and you can go ahead and put that on your calculator. I'll show you how to do that if you don't know how. You can find your square root button just here. The second row is 106. And that gives you, let's go to 2 decimal places. In fact, let's just go to 1 decimal place. 10.3. In this case, centimeters. And there you go. So they're the steps you really should be showing. I've sort of shown everything. You can maybe cut out 1 or 2 of these, but essentially, draw your triangle, start with the equation, label your triangle, substitute the values in, and then solve following this process. Okay. The second example I wanted to show you today was finding an unknown if it was a shorter side. A similar process. We've got our right angled triangle here. In this case, we do have the value of the hypotenuse. The longest side here is 1.5 meters. But let's, start by writing Pythagoras' theorem, which is a squared plus b squared is equal to c squared. And then label our triangle. Hypotenuse is always c. A and b, doesn't really matter at this stage. Let's call that a, let's call that b. And then substitute our values into this equation. So instead of a, this time I'm using 1.1. Instead of b, I'm using the pronumeral x. And instead of c, I'm using 1.5. So here you can see I've got my unknown on the left-hand side of the equation. But we're still going to just, follow the process step by step and solve for that unknown. So I'm going to start by squaring 1.1, which is 1.1 times by 1.1. It's 1.2 of it, sorry, on the calculator, 1.1 squared, just next to the square root button there. is equal to 1.21. We're going to keep x squared the same there for now because we don't know what that is. And that's equal to 1.5 squared, which is 2.25. Okay. Now we're at a stage where we're going to use a little bit of algebra to solve. So we want to isolate the x. And because I've got 1.21 on the left-hand side, to remove that, take it over to the right-hand side here, I'm going to subtract it from the left-hand side. But if I do that, I also need to subtract it from the right-hand side. Okay, so I'm then left with x squared equals 2.25 minus 1.21, which would give me 1.04, if my maths is correct. Now we're at the stage where we were a number squared equals 1.04, or x equals the square root of 1.04. Okay, and again, use your calculator to work that out. Square root of 1.04, and let's go to 2 decimal places this time. There we go. 1x equals 1 point. If we're going to 2 decimal places, I'm going to round that up to 1.02, and in this case, it's meters. Okay. So guys, hopefully that helps. You can see that unknown shorter side is a little bit more trickier than finding the unknown hypotenuse because there's a bit of algebra here, but essentially it's still just following that process. Once you have a go at a few questions, you get the hang of it, you'll be able to sort of move on to some more of the application questions and look at using Pythagoras Theorem in 3D shapes as well. All right, thanks for watching.